morning, children. Today's class we are going to recall quadratic equation what you had studied in standard 10. Now quadratic equation, how will it look like? Ax square plus bx plus c equal to 0. Now we write a quadratic polynomial is ax square plus bx plus c. If I put equal to 0, I call quadratic equation. If I simply put ax square plus bx plus c, it's quadratic polynomial. Given alpha and beta are the roots, I can say alpha plus beta is minus b by a and alpha into beta is c by a. And if I know the roots, I have a formula like this: x square minus sum of the roots into x plus product of the roots equals to 0. Can I write it here like that? Yes, but remember, put a k extra. X square minus sum of the zeros into x plus product of the zeros. But very important is we do not put equal to 0. So k will come. This k has to be found out from the given conditions. But in quadratic equation, right hand side 0 implies I need not put any k here because 0 by k is 0. So we have sum of the roots, product of the roots as before in 10th standard. And the next important idea is the formula. How do you solve it? Minus b plus or minus root of b square minus 4ac by 2a. So it's a famous formula. We say for quadratic equation, whenever factorization is not helpful, we go with a formula. So formula method is useful for any sort of roots. Now this idea, what is inside the square root? B square minus 4ac. This b square minus 4ac I call del, discriminant. This discriminant positive, equal to 0 or negative. If it is positive, my answer, see quadratic, whenever I say the diagram is opening up a curve like this, which you had done in 10th standard practical geometry. Any x square, some x, some constant, when you draw, it would be like this. When it is greater than 0, the curve cuts x-axis at two different points. When it is equal to 0, the curve touches x-axis at only one point. And when it is less than 0, the curve is entirely above the x-axis. So this will help us to find out. Discriminant positive, we have two real roots, distinct roots. Two answers I will get. 2, 4, let me say the 2 points. If it is equal to 0, it is 2 only, 2, 2. And if it is less than 0, the answer is imaginary, which we cannot find out. So these are the basics in quadratic equation. Let us proceed with the exercise. A very simple problem. Quadratic equation to be formed with the root 7 and minus 3. Let us write down sum of the roots. 7 minus 3 equals 4. Product of the roots. 7 into minus 3 equals minus 21. The equation, the formula, x square minus sum of the roots into x plus product of the roots equal to 0. Or I say x square minus 4x minus 21 equals to 0. And that is the answer. Question number 2. Find the quadratic polynomial with one of its zeros 1 plus root 5 and it satisfies p of 1 equals to 2. Given 1 plus root 5 is 1 root, implies whenever we are finding square root, plus or minus would come. So whenever 1 plus root 5 is 1 root, we immediately declare 1 minus root 5 is also a root. So how many roots we have known now? 2 roots. Find out, we shouldn't say it as a root. Remember, it is a 0 because it is not an equation. It's a polynomial. So what should I say? 1 plus root 5 is a 0 implies 1 minus root 5 is also a 0. Now, what is sum of the zeros, product of the zeros? No need. I can directly write in this model. My question is polynomial. I have to write k x minus first 0 into x minus the second 0. See how we write x minus alpha, x minus beta. That pattern we have written. Remember to put k because quadratic equation I need not put k. Quadratic polynomial right hand side is not 0. So definitely I must put a k here. Now we shall simplify this answer. I have k into, what pattern is this? A plus b into a minus b model. Let me try to write it. X minus 1 minus root 5 into x minus 1 minus into minus plus root 5. So this is a and this is b. So what format is it? A plus b into a minus b. I can write a square minus b square. So this is k into x minus 1 the whole square minus root 5 square, which I can simplify as k into x minus 1 the whole square minus root 5 square is 5. Now we'll use this condition. So this let me call p of x. What is given? P of 1 equals to 2. That implies wherever x comes, let me put 1. Wherever p of x comes, let me put 2. So this is actually p of x. So 2 equals, let me substitute here, k into 1 minus 1 the whole square minus 5. Or this implies 1 minus 1, 0. 0 you forget, 0 minus 5, minus 5. So minus 5k equals to 2. That implies k equal to minus 2 by 5. So once I get what is k, put it back in p of x. So what is p of x? K value minus 2 by 5, x minus 1 the whole square minus 5. I can stop the answer with this or further expand that x minus 1 the whole square. Minus 2 by 5, this is a minus b the whole square. A square minus 2 into x into 1 plus b square minus 5. Or if I simplify, p of x is equal to minus 2 by 5 x square minus 2x, 1 minus 5 is minus 4, and that is the answer. We'll see the steps once again. Given a quadratic polynomial with 1, 0, 1 plus root 5. We immediately declare whenever 1 plus root 5 is 1, 0, the other 0 will be 1 minus root 5. Root symbol comes. It is coming in pairs, irrational roots. Plus root 5 comes, I immediately put minus root 5. So I know 2 zeros. How to write the polynomial? We write k x minus first root into x minus second root. This is of the form a plus b, a minus b, which I can rewrite a square minus b square. And once I declare what is p of x, let me use this condition. P of 1 is 2. Wherever x is coming, put 1. So p of x, let me put 2. From that I get k, put it back here and simplify. We arrive at p of x is equal to minus 2 by 5 x square minus 2x minus 4. Question number 8. Discuss the nature of roots. Now given ax square plus bx plus c equals to 0. Discriminant we call del equals b square minus 4ac. Del greater than 0, real and distinct I say. Del equals to 0, real and equal we say. And del less than 0, it is not real. So we need to do all this in this particular problem. Ax square plus bx plus c, if I compare a equals -1, b is 3 and c is 1 as we compare. Discriminant b square minus 4ac. 3 square minus 4 into -1 into 1. 9 plus 4, which is positive. I declare the roots are real and distinct. Same pattern, the second problem. Ax square plus bx plus c equals 0. A is 4, b is no number implies -1, c is -2. Del is b square minus 4ac. -1 square minus 4 into 4 into -2 as we substitute. It is 1 plus 32, which is positive again. So I say the roots are real and distinct. The word distinct implies not equal. So unequal roots I get. Here a value 9, b value 5. There is no constant, c 0. So del equals b square minus 4ac. Del equals 5 square minus 4 into 9 into 0, or I get 25. Again it is greater than 0. So I will say real and distinct roots. So as we calculate b square minus 4ac, based on that, let us conclude the answer. Question number 9. We are given 3 different equations. We need to say whether they intersect x-axis at 2 points or 1 point or no point. Again we use the discriminant idea only. What is a, b, c? Let us write. A is 1, b is 1, c is 2. I need to find the discriminant. B square minus 4ac. 1 square minus 4 into 1 into 2, or it is 1 minus 8, that is less than 0. So when I get less than 0, I declare the curve does not touch x-axis. Remember the idea? Discriminant is negative. The curve does not touch x-axis. Second case, a value 1, b value -3, c value -7. Del is b square minus 4ac. B square is -3 square minus 4 into 1 into -7. 9 plus 28. So my answer is positive. I immediately declare the curve cuts x-axis at 2 points. We are not asked to draw the graph. We need to say, that's it. So positive cutting at 2 points, negative does not touch. Coming up to the third model, a value 1, b value 6, c value 9. Find del. B square minus 4ac. Del equals 6 square minus 4 into 1 into 9. 36 minus 36, that is 0. When del is 0, we declare the curve touches x-axis at only 1 point. So notice the 3 different cases. Del negative does not touch. Del positive touching at 2 points. And del is 0. It touches at only 1 point. For your clarity, this need not be done in the exam, but you should know. It touches at one point. This is the diagram. Cutting at 2 points. This is the diagram. Does not touch. The curve may be somewhere like this. So this is only for your example and you need not do this in the exam. But remember, the discriminant itself tells how the curve will be. Question number 10. Write in completed square form. F of x is given like this. What we do? First, let me check x square has coefficient 1. Second step, whatever number is with x, that is 5, divide by 2. So, x square plus 5x plus 4, the given question. With this, whatever number is here, divide by 2. So, I get 5 by 2. Add the square, subtract the square. So, whatever number is here, divide by 2, add the square, subtract the square. Now, these three things, let me join. What formula is this? A square plus 2ab plus b square. Or I will say it is a plus b the whole square. To arrive at this format only, we do this operation. Plus 4 minus, we have to add these two now. 25 by 4. Simplifying this, x plus 5 by 2 the whole square. 4 is the LCM, cross multiply. 16 minus 25. So this I write as x plus 5 by 2 the whole square. 16 minus 25 is minus 9 by 4. One more step, x plus 5 by 2 the whole square minus 3 by 2 the whole square. So, the given expression x square plus 5x plus 4, I am able to write as a difference of two squares. Square of something minus square. Either minus or plus will come in the other problems. So, it's a technique of expressing a given quadratic function as sum of the squares or difference of the squares. And this model we call completed square form. So, today we have done each model one problem, majority repeated from standard 10. Let us recall and reinforce in learning. Thank you. Good morning children. We proceed with quadratic equations. Exercise 2.4. Many of the problems are again same pattern as that of standard 10. One root of the given equation is double the other. So first let us restate this equation. K into x minus 1 the whole square minus 5x plus 7 equal to 0. Let us simplify this. A minus b the whole square. X square minus 2x plus 1 minus 5x plus 7 equals to 0. Multiply with k. Kx square minus 2xk plus k minus 5x plus 7 equals to 0. Combine x terms, combine without x and x square term. Kx square plus, I am taking x. Here I have minus 2k minus 5. I am taking all that is without x. K plus 7. This is equal to 0. Now what is the root? Alpha comma beta are the roots of this, let me say. Given one root is double the other. Beta equal to 2 times alpha. So this only we call one root is double the other. Now I want to write sum of the roots. The formula is minus b by a. Product of the roots, the formula is c by a. This implies sum of the roots. One root is alpha, another root is 2 alpha. Product of the roots. One root is alpha, another root is 2 alpha equals to minus b by a. This is B and this is A. So minus B means change the symbol. 2k plus 5 by A is K. C by A. This is C and this is A. K plus 7 by K. From this, I get alpha plus 2 alpha. 3 alpha equals to 2k plus 5 by K, or alpha equals to 2k plus 5 by 3k. From this, wherever alpha comes, I can put 2k plus 5 by 3k. So this is 2 alpha into alpha is alpha square equals k plus 7 by k, implies 2 into wherever alpha is coming, 2k plus 5 by 3k the whole square equals k plus 7 by k. Let us simplify this answer. 2 into, expand this a plus b the whole square, 4k square, 2k the whole square, plus 2 into 2k into 5. 2 into 2k, 4k, 4k into 5, 20k. Plus 5 square is 25. Whole thing divided by 3k the whole square will become 9k square equals to k plus 7 by k. 1k and 1 square I can cancel. Let us cross multiply. First of all here, 2 into 4k square, 8k square. 2 into 20k, 40k. 2 into 25, 50. Cross multiplying, 9k into k, 9k square. 9k into 7, 63k. This implies bringing everything to the same side. 9k square, 63k. Bring all this to the right side. Minus 8k square, minus 40k, minus 50 equal to 0. Or I am reduced to 9k square minus 8k square is k square. 63k minus 40k is 23k. Minus 50 equal to 0. Solve this equation and find out k value. As I try to solve, I can try with factorization. It is k square plus 23k minus 50 equals to 0. Minus 50 and 23 tells me 25 twos are plus plus minus. So I get k plus 25 into k minus 2 equals 0, or k equals 25 and 2. That is the question. We need to show k value is 2 or k value is minus 25, and that's the end of the problem. Question number 5. Given a quadratic equation and difference of the roots is equal to their product, we want to show that a value is 2. First, let us proceed. Alpha comma beta, let be the roots. Let alpha comma beta be the roots. What is alpha plus beta minus b by a? Alpha into beta c by a. So minus b value is minus of a plus 1 by a value is 2. Alpha into beta, c value is a minus 1, a value is 2. This implies minus and minus cancels, a plus 1 by 2. Alpha into beta is a minus 1 by 2. Product is nothing but difference of the roots. So they have given product equal to difference. That implies alpha into beta equals to alpha minus beta. So alpha beta answer I can put for alpha minus beta also. So alpha minus beta equal to a minus 1 by 2. Solve these two. call this as number 1, number 2 and number 3. So let me add 1 and 3. Alpha plus beta plus alpha minus beta equals to a plus 1 by 2 plus a minus 1 by 2. Beta gets cancelled. 2 alpha equals to LCM 2 a plus 1 plus a minus 1. Plus 1 minus 1 cancels. So I am getting 2 alpha is equal to 2a by 2. 2 cancels. So alpha equals to a by 2. I have achieved one answer. Put alpha value in first equation and get what is beta. So substitute alpha equals a by 2 in first equation. A by 2 plus beta equals a plus 1 by 2. Beta equals to a plus 1 by 2 minus a by 2. 2 is the LCM. A plus 1 minus a, that is 1 by 2. So I have attained beta equals to 1 by 2. Having known alpha and beta from equation number 1, let us put it in equation number 2. So substitute alpha equals a by 2, beta equals 1 by 2 in second equation. Alpha into beta, a by 2 into 1 by 2 equals a minus 1 by 2. 2 we can cancel, cross multiply. I get a equals cross multiplying 2a minus 2. Bringing to the same side, 2a minus a equals 2. Or I get a value is 2 and that is the question. Question number 7. We are given two equations stating the fact that two equations have one root in common. Second equation has equal roots. Show that some relation is given. So let me take the first equation, x square minus ax plus b equal to 0. Alpha comma beta are the roots. Immediately we can write alpha plus beta is minus b by a. In this question, a value 1, b value minus a, c value b. So I get a by 1. Alpha into beta is c by a. C is b and a is 1. So from these two I get alpha plus beta is a. Alpha into beta is b. So this is an important relation. Call this as 2 and 3. Now we'll go on to the second equation. X square minus ex plus f is equal to 0. First condition states that both have one root in common. So out of alpha and beta, let me call alpha is the root. Second statement says if they have equal roots. So second root is also alpha. So alpha and alpha are the roots. See whether the condition is satisfied. One root is common and here both the roots are equal. Apply the same condition. Alpha plus alpha is minus b by a. I get e by 1. Alpha into alpha is c by a, that is f. So this gives me 2 alpha equal to e or alpha equal to e by 2. Mark the condition. 4 and this is 5. Alpha into alpha tells me alpha square equal to f. Mark this condition as 6. Now using 2, 3, 5 and 6, try to achieve the expected question. Substituting 5 in 6. Alpha square is, so 5 comma 6 implies alpha square is e square by 4 equals to f, or e square is equal to 4f. So this we will use later. Same way, substituting 5 here. 2 comma 5 implies alpha is e by 2 plus beta equal to a, or beta equal to a minus e by 2. Call this is next number, say 7. Put this in third equation. So what is third equation? Alpha value e by 2, beta value a minus e by 2 equals to b. Multiplying this, it is ae by 2 minus e into e, what do I get? E square by 4 equals to b. This implies ae by 2 minus, in the place of e square I can put 4f by 4 equal to b. 4 and 4 will get cancelled, or ae by 2 equals b plus f, or ae equal to 2 into b plus f, and that is the question expected. So using 5 I get squaring e square by 4 equal to f. This 5 I substitute here and get what is beta. Alpha and beta I substitute in third equation. In the third equation, wherever e square is coming, I can put 4f. Simplifying, we get the expected result. Question number 6. Given an equation ax square plus bx plus c equals 0. We just need to derive some conditions. First question says, one root is negative of the other. So one root is alpha, means the other root will be minus alpha. So I can say sum of the roots alpha minus alpha equals to minus b by a. Product of the roots alpha into minus alpha equals to c by a. This implies alpha minus alpha is 0. Or I will say b equal to 0. So a into 0 is 0. So b is equal to 0. First condition. Second, thrice the other is given. So one is alpha, means another one is 3 alpha. Sum of the roots alpha plus 3 alpha equal to minus b by a, or adding these two, 4 alpha is minus b by a, alpha is minus b by 4a. Product of the roots alpha into 3 alpha is c by a. Wherever alpha comes, put minus b by 4a. Minus b by 4a, 3 into minus b by 4a equals to c by a. 1a I can cancel. Cross multiplying, minus into minus plus, 3b square equals 4 into 4, 16a with c, 16ac. So the condition is 3b square minus 16ac equals to 0. Third one says reciprocal of the other. So if I take alpha as one root, the second root is reciprocal. Reciprocal means 1 by alpha. So what is sum of the roots? Alpha plus 1 by alpha equal to minus b by a. Product of the roots alpha into 1 by alpha is c by a. So alpha alpha cancels, cross multiply, c equal to a. In the place I can substitute cross multiply. So call this as equation number 1. First equation implies But only condition is asked, so we can stop with this. C is equal to A is the answer.